let's go over the basics of the periodic table. We're going to go into a lot more depth on the periodic table in Chapter 8, and even just in general throughout the course. But let's start with the basics. What are the basics? Okay, first, periodic. Why is it called the periodic table? Okay, the reason is because with the way it's organized, you have this periodicity in terms of the physical and chemical properties of elements. For example, if we come to oxygen, and then we go forward 8 elements in line, we get to sulfur. Or fluorine, we go 8 elements in line, we get to chlorine. Helium, go 8 elements in line. Neon, go another 8 elements in line. Argon. Oxygen and sulfur. Fluorine and chlorine. Helium, neon, and argon have very similar physical and chemical properties. In fact, that's one of the main features of the periodic table. Columns in the periodic table, which are called groups, columns of elements, in general, are going to have very similar physical and chemical properties. Okay, so this column here, the noble gases, at room temperature and pressure, these are all in the gaseous state, these are all gases, but furthermore, chemically, they're all very stable gases. Okay, this second column here, the alkaline earth metals, at room temperature and pressure, all of these elements are solid metals. So not just solid, but metals, shiny, ductile. Okay, but furthermore, chemically, these are all reactive metals, as opposed to this column here, copper, silver, gold. So this group, you've got solid metals at room temperature. However, the difference is that these, as we know, are very stable metals. Okay, so that's what periodic means. That's why it's called the periodic table of elements, because you have this periodic pattern between elements as you go from period to period. So rows in the periodic table are called periods. And again, if you start at one element and then you go period to period, you have this consistency, this synchrony in chemical and physical properties between those elements. Okay, but now, how exactly are the atoms organized, right? Because anyone can just take elements and put them into categories based on if their physical and chemical properties line up, right? But what was the idea of, so you start here, and then you go 8 elements in line to get here. You start here, you go 8 in line, then 8 in line. 8 in line in terms of what? What is the underlying property of the elements that matches up with this synchrony in physical and chemical properties? Okay, well, originally, when the periodic table was first being developed in the mid to late 1800s, the atoms were ordered based on atomic mass, the mass of the element. So shown here, here's the atomic weight of iron. So the lightest element was first, the second lightest second, third lightest third, etc. And this worked remarkably well as far as when they were ordered in terms of atomic mass. You did get this periodic alignment of physical and chemical properties. However, what they found was that this wasn't foolproof. There were some deficiencies. So, for example, if we look here, argon has an atomic weight of 39.948. So now if we go next in line to potassium, based on atomic weight, potassium should weigh more, but it doesn't. 39.098. So if we're ordering by atomic mass, potassium should be here and argon should be here. Okay, but now what they found was that the more precise way that the elements should be ordered to more precisely line up with this synchrony of periodicity in physical and chemical properties is based not on atomic mass, but on atomic number. Shown here, the atomic number of iron is 26, and the atomic number is an integer that corresponds to the number of protons in the nucleus of the element. Okay, and so today, that's how the elements in the periodic table are ordered, based on atomic number. Okay, now, all of the elements to the left of this line are metals. So note that includes these two periods as well, the lanthanides and the actinides, because these two periods just technically squeeze in here, like shown here, right? They just squeeze in. So this is technically what the periodic table looks like. All elements to the left of this line are metals. Not including hydrogen. Hydrogen, technically, as far as physical and chemical properties, comes over here. Okay, so yes, metals. The majority of the elements in the periodic table are metals. And a metal is just what you think it is. Most of the time, at room temperature and pressure, it's a shiny, ductile solid. You might be saying, well, wait a minute, like sodium. When I think sodium, I think salt, right? That's not a metal. Well, no, that's sodium chloride. Sodium combined with chloride. Pure sodium is going to be a shiny, solid metal, and it's going to be very reactive. You can go watch videos on YouTube of people throwing alkali metals into water, into rivers. Don't do this without the proper precautions. But yes, if you put pure sodium into, or any alkali metal into water, you're going to get a extreme reaction. Okay, now, so yes, most of the time at room temperature and pressure, metals are going to be solid, but there are special cases like mercury, for example, where at room temperature and pressure you have a metallic liquid. So a shiny metallic looking liquid. Okay, now from a chemical perspective, the main characteristic of a metal is that if it's going to create an ion, go into an ionic state, the vast majority of the time, this is going to be a cation. It's going to give up one or more electrons. And the general way to think about this is that metals are electropositive, in that when it comes to bonding, they have a greater tendency to reject electrons and become positively charged. And so again, everything to the left of this line here, all of these elements except for hydrogen are metals. All of this. The vast majority of the elements in the periodic table are metals. Okay, now, going to the right of this line, this next group of elements are metalloids. They have intermediate properties between metals and nonmetals. They'll form both cations and anions. They'll have a mixture of metallic and non-metallic physical properties. Okay, so continuing to the right, all of these elements, including hydrogen, are the nonmetals. Chemically, nonmetals, in general, in an ionic state, a nonmetal is going to form an anion. So it's going to accept electrons. And the general way to think about this is that nonmetals are more electronegative, in that when it comes to bonding, they have a greater tendency to attract electrons and become negatively charged. Physically, nonmetals, we can see in terms of room temperature and pressure conditions, these last two columns are mostly gases. Bromine, though, is a liquid. Nitrogen and oxygen, we know, are gases. Carbon, phosphorus, sulfur, and selenium are solids at room temperature and pressure. So characteristics of nonmetals from the solid perspective are that they are dull and brittle, as opposed to shiny and malleable like metals. Nonmetals are poor conductors of heat and electricity, the opposite of metallic character. And since we can see that many nonmetals at room temperature and pressure exist as liquids or gases, nonmetals in general have low melting and boiling points. Okay, so there's an overview of the basics of the periodic table.